Dear participants, welcome you all to the 3-day webinar on protection, switchgear and safety. I am Dr. Karthikeyan, Professor, PSNA College of Engineering and Technology and Coordinator for the PSNA Voltech COE. I would like to thank our PSNA management, principal, our beloved HOD and my faculty friends. Also, I thank Voltech management for their continuous support for the 3-day webinar. The PSNA Voltech COE is established in the year 2019 at PSNA CET in collaboration with Voltech Engineers, Chennai. It is a Voltech authorized switchgear protection training center. The lab is established with 33 kV vacuum circuit breaker, 100 kVA transformer, different types of relays, and relay testing, CTPTs to provide industrial training. The 3-day sessions are going to handled by Mr. L.T. Arjun Raja, Manager, Voltech Engineers, Chennai. Also, he is our renewed alumni of EEE PSNA CET. Now, I handed over the session to Mr. Arjun Raja. Thank you.
Good morning to everyone. It's a great morning, and we have a quite interesting topic to do. And we have some interesting things to learn when we are in home. Now we're going to start our session. Please tune yourself with us for further updates. So, introduce myself is Arjun Raja, and I'm working with Voltech since 2011. Also, I'm a product of PSNA. So, I'm going to handle another 3 days with the protection relay, protection switchgear. Let's start our session today. So, first, tune your webinar series for another 3 days. And today we have some interesting topics. Next, set your device in the proper place and with the network. Place your valuable time for 1 more hour. We are going to engage with us, and knowledge will increase with our sharing. So, just give an overview about the day 1. So today we are going to talk about the overview of switchgear and some more products. What are the products available in the switchgear, how the switchgear is constructed, and next the necessary thing is the schematic, how the schematic is used in the field of power system, why it's used, what are the symbols, what are the ANSI codes, how to read the schematic. So we are going to see about this one. Next is type of busbar arrangements. We have different type of busbar arrangements in the power system in the field of electrical. So next is finally we are going to talk about the basic about the electrical safety. What are the safety things we have to follow during the work. So let's start our session. So first, I'm just talking about the switchgear. Don't be bored. So switchgear is a compartment with mechanical and electrical components to do the switching operation or isolate during the fault organized by the protection relays. This switchgear is placed mostly in the medium kV, lower kV, and also in the medium kV level they use the switchgear. If you go higher kV, the switchgear is removed, but in the place of switchgear we are using the outdoor equipments like isolators and breakers. So most probably the switchgear is a basic concept to understand the power flow and how the fault and detections is happening and how they are isolating the power flow. Now we are talking about the switchgear constructions, mainly based on the how we are going to construct the switchgear, what are the parameters involved and what are the components involved in the construction of switchgear. So mostly we have four chambers we are talking about in the switchgear construction. One is breaker chamber. Breaker chamber is mainly placed in the middle portion of the switchgear compartment. It's consisting of circuit breaker with these auxiliary circuits. So next one is cable chamber. Cable chamber is the exit or entry point of the switchgear, which is used to evacuate power through cables or input through the cables. So next one is control and protection. That means control and protection means we have to operate the circuit breakers, we have to isolate the circuit breaker during the fault session. So we have to place some control things, control relays or protection relays on the panel that is used for fault detections, also isolation, and also for the operation, manual operation. So finally the busbar chamber. The busbar chamber is nothing but the connection between next one panel to another panel. It's a common thing which is connecting to the input and output. So the busbar is very common thing used in the switchgear and also in the switchyard. So now this is the internal components of switchgear. So now we talk about the major chambers. We in the previous slide we saw there is a four major chambers in the circuit breaker, that means the switchgear constructions. Now we are going to about how the components are placed. So here I will explain. So this is the place where the circuit breaker is placed. So this is the portion which is connecting with busbar and the external cable. This is the cable chamber. So this cable chamber is connected with this circuit breaker. So this circuit breaker is connected with the busbar. So whenever we are placing the circuit breaker between the busbar and cable, this is the switch. It's a heavily operated switch which is operating the power flow. It's controlling the power flow. So next is we're talking about the busbar. This is the busbar portion of busbar which is connected to the next panel, and this is the cable chamber which is connected to the input or output. So this is the control and protection panel. Here we place the switches for control and also we place the protection relay to isolate during the fault condition. So here one more panel, this is called arc chamber. Whenever the fault occurs or short circuit occurs in the busbar chamber, this chamber is used to evacuate the smoke from these places. So this is called arc chamber. And here this is air switch. So now we are talking about the internal components. So we can say this is arc chamber. This is a low voltage compartment which is the auxiliary volt for protection and control is 110 or 220 BC. So then talking about the busbar. The busbar is made by a copper or aluminium. Depends upon the kV. We using the busbars. In lower kV we use aluminium. If you go for medium kV we use the copper. And next one is circuit breaker. This circuit breaker, already I told you, this is circuit breaker portion. So this is the arms of circuit breaker. One is connection to the busbar, one is connecting to the cable. This cable is connected here, and this is the current transformer which is used to measure the current, and this is the potential transformer, and this is the air switch we are placing here. The air switch is used to grounding the system, and this is the earth bar for this whole compartment. Next we talk about the another equipment, that means components in detail. Now we are going to detail components, means we have some major components: current transformer, voltage transformer, circuit breaker, bus bar, air switch, protection relays, control switch, and meters. So now we talk about in detail. So current transformers, It's a type of instrument transformer which is used for current measurements. That means converting current from higher kV current to lower kV. This will not. This will convert simply the current from higher rating to lower rating. So this is the basic arrangement for CT. CT is always in the series connection. CT should be always in the closed position. So here, this is the conductor carrying the current. This is the arrangement of CT, and here we are measuring the current in the secondary side. So the primary is made up of same type of transformer windings, and the secondary also some windings. Depending upon the ratio, the winding will be differs. So this is the circuit symbols. That means this is the construction type. We just showing the symbol how it will be. Whenever the primary current is flowing here, there is a secondary current in the secondary side of the windings. And the current flow, how the current flow will be. So here I will explain the current flow. Whenever the current flowing in the primary side, the secondary side always getting the current, but the secondary current is always in the opposite direction, externally opposite direction to the primary. So here the IP is a primary current and IS is a secondary current. Whenever the current flow is from primary, this is the terminal names. P1, P2 means terminal names. Primary 1, primary 2, the side names, side 1, side 2. Whenever the current is entering in the P1 and leaving in P2, the IS, the secondary current, will start from secondary 2 to secondary 1. This is external direction. Okay, so this external direction is opposite to the primary direction. But after the measurements, this will come to the same direction. See the IP and IS in the same direction. See this IP and IS in the same direction, but external flow is opposite. Why? Because of the transformer having the phase shift. So this is the current flow direction. So next we go for the types of secondary windings. CT having different type of secondary windings. Depends upon the ratio, we can change the types of secondary. So this is a single winding. One primary, that means primary 1, primary 2 is always a simple bar or a simple rod. The secondary will be changed everywhere. Depends upon the application, we can change the secondary. So always we call it as secondary 1 and secondary 2. This is single winding, so we call it as secondary 1. That means secondary is only one secondary, so we can call it as S1, S2. The terminal is S1 and S2. So we have different type of windings. This is a simple single winding. So now I will show you the next one. This is a secondary with the tappings. Single winding with the tappings. Here this is the only one ratio. Whenever the current is 200 ampere flowing in the primary, to generate 1 ampere in the secondary. But here the same type of winding. Here we have one tap in between the S1, S2 and S3. Here we can measure the 300, the same 200 ampere. We make one more tap in here. S1 to S3, if you measure, it will get 200 ampere. S1 to S2, the half of the winding, so you will get 100 ampere. So depend upon our application, we can use this type of CT windings. And also we can use multiple windings. This is single winding. This is single winding with the tappings. This is multiple winding. This is not a double winding, it's a multiple. We can use some more, but for presentation I will give double winding. So here both are measuring the same current, S1 to S1. That means here if you go for multiple winding, it's showing 1S1, 2S1. 1S1 means the first core, 2 means second core. We can go up to 5 cores. So here 1S1, 1S2 is given the ratio of 200 by 1. The same 2S1, 2S2 is giving the same ratio. So depend upon our application. That means one is going for metering, one is for going for protection, or if you want to give the remote measurements or remote monitoring, we can add the windings. So we can specify the winding for type of application. One protection and monitoring. So next one is circuit breaker. This is the portion we are showing. This circuit breaker, this is the arm. This is a circuit breaker construction. We have the circuit breaker, that means we can pull inside the circuit breaker inside the panel. This will give the this will connect the bus bar and the cable. So this arm is going to connect with the bus bar, and this arm is going to connect with the cables. So here this is the interrupter. This is we call it as, this is arm, and this is the bottle or interrupter. This interrupter is a vacuum or air or SF6. So next is type of circuit breaker. Explain some types we are using. So one is oil circuit breaker, but nowadays we are not using any oil circuit breakers. And the next one is air circuit breaker. This is a vacuum, and air circuit breaker we are mostly using in the LV side, not in the HV, but vacuum we are using in the MV side. SF6 is mostly we are using in the HV side. Some places they are using in switchgear also. So this is the construction, internal construction of interrupter. One is fixed on and one is moving on. Why I am skipping the oil and air circuit means it's very simple construction, so that's not tedious to, that means it's not difficult to know about that. So vacuum and SF6 is somewhat different than this. So I am going to explain about the vacuum. So this is the vacuum interrupter. This place is filled with the vacuum. Why we are filling vacuum means, if there is no air, there is no chance of arc. So here the vacuum pressure is -7 to minus, that means -5 to -7 torr the pressure level is, and this vacuum breaker is used up to 33 kV. Here this is fixed on, this is moving on. This moving arm is connected with some mechanical arrangements to move this arm to connect or disconnect the circuit. So advantage means it's a compact and no hazardous gases inside, so no chance of fire, and it's required only a simple control and also low noise. So here I am going to show about the SF6. SF6 is mostly used in the switchyard. This is for higher kV. After that means above 66 kV we are using, from 66 kV onwards we are using these SF6 breakers. So this gas is SF6, so there is no arc formation, and electronegative gas, it's strong, and sometimes its pressure is, that means the pressure is high pressure flow also available, and free from electron. So this is the internal construction of SF6 breaker. So this internal, see, you can see the first picture, it's showing the connected position. The next one is its opening position. The third one also it's a opening position, and finally the fourth one is complete open position. So advantage means it's a simple, compared to vacuum or any other things, the cost is low. For higher kV, if you go for higher kV, the cost is low and the maintenance free, able to interrupt in the high fault current. It can withstand in the high fault current also. Excellent arc extinguisher. So this is the busbar arrangements. See here, the busbar is made by copper. I told you before, the copper bar, it's connected from one panel to another panel. So we are here, see, this is the construction of busbar. That means connection, it's already made, the connections are made between all the panels. So one is going to the cable and one is going to the next feeders. See, this is one feeder, 2, 3, 4, like that. So this busbar is connected between these feeders. Once after the connection of busbar, if you give the input to the busbar, this will give output to all the feeders. It's common to all the feeder. Any feeder if you want, you can turn on, you can draw the power from the busbar. So busbar is simply a conductor. It will not generate or distribute. It's used for only for distribution. Earthing switch. Earthing switch is simple construction, mechanical construction we made in the switchgear. The bottom of the switchgear we connect the external circuit. That means external circuit we should not interrupt with our busbar or any other breakers. If you want to take a maintenance, you have to disconnect the external circuit and make earthing for the safety. So for that we are using this air switch. For this air switch is mechanically operated. We can pull by manually to close or open the circuit breaker. Sorry, air switch. And the control switch is simple switch. We are going to use the control switch for operation of the breaker. That means if you are going to make any operation, close or open or any other things, you can do with this switch. This is electrical switch. Even there is one more option in the breaker. You can close or open the breaker by manual. This is electrically operated switch. We can close or open the breaker by using these switches. Here it's written as a trip and here it's written as a close. So if you turn this switch to this side, it will trip the breaker. That means open the breaker. If you turn this side, this will close the breaker. So next we go for the interesting thing, the protection relay. The protection relay is an electronic device. Now we are using electronic device, smart device. We can use it now. It's used for monitoring, also the fault clearance. Also we can use the device for remote communication and alarm, records, everything. But in ancient days we are using different type of relays. So this is the basic functions of protection relay. When the input will be current, voltage or isolation temperatures, different type of inputs is available, and settings will be a pickup levels or time. Pickup level means we have to give the range for the current, how much the current should be. We should limit the current, so we should not allow the current flow, so we can give the limitations here. The time is how much time I have to allow this much of current. So everything is given to this relay, and the protection relay will give the output as a visual indication. It's a light or alarm, communication or remote power. It's simple. It's alarm means it will shows in the relay itself. Visual inspection, you can read the fault, what are the faults or any measurements in the relay itself. There is a screen. The communication is nothing but SCADA. We can use this protection relay to the SCADA. We can take the information remote. So the types of protections is, it's nothing but we are just talking about the types of protection relays. Before there is electromechanical, after that it came to the electronic devices. Now we are using smart devices. So electromechanical is completely made by the electromechanical components. It's winding and everything. Whenever the current flows, the winding is picking up slowly and it will give the fault or any other indications. But the tolerance is more because of the electromechanical arrangement. The losses are more. It's give more error. So next time, after that, the evolution of microprocessor and electronic devices. Electronic devices is nothing but a static. It will give 1 or 0 like that. Its accuracy and is less in size, but the problem is it's not a multifunctional. So we go for the multifunctional. Now we are in the place of IED. That means numerical relays. We call it as IED. Numerical relay is made by electronic components, but having a multiple functions. So nowadays all the major manufacturers are doing with the IED relays. So this is a one relay with multiple functions. We can use for monitor, we can use for protection, we can use for communication. Everything we can use with a single device. So next is single line diagram. Single line diagram means, I think you all know about the single line diagram. It's a diagram. We have to represent our design or power flow or any other constructions in a single line. It should be clear to everyone. So it's a simple. It's depend upon the system voltage and substation position, which means what are the components involved in the substation, and also it will the SLD itself, it will shows the cost of the substation. So now I will show you how to what are the components involved and what are the requirements we need to construct the SLD. The SLD is the major thing. Before going to execute any projects or any manufacturing, we should be prepared this SLD. The SLD itself, it shows how much cost, how effective, what are the advantages, drawbacks, everything is available in the projects. So SLD is the initial stage to decide the projects. So it should be simple. SLD should be simple to understand everyone. Also economy. Economy means we should reduce the cost. Minimum interruption of supply. That means the SLD you should prepare. You have to avoid the interruption of power always. We have to design like that. Then safety. Safety is very much important because the humans are going to work around the projects or power sectors. So we have to consider safety of the peoples. Easy for maintenance. It should be easy. The maintenance should be easy. That means any other outages is coming, we have to maintain in the less time. Then alternate power arrangement. That means if there is a outage or any other things is coming means any other coming means we have to arrange alternate solution to avoid the power interruption. So SLD itself we have to shows everything. Now this is a simple SLD is showing clearly about the power flow. Here one generator and 3 loads. That means source is one source and we have 3 loads. So here it's showing the generator, it's connected to the common bus bar. So here don't think this is the bus bar, this is the network. We call it as network. So this is a power flow single line diagram. So power is generated from the generating station, it's connected to the network. The network is connected to some other loads, maybe a industry or maybe a domestic, any other things. So this is a simple construction. So the arrow itself showing how much the energy generated, it's given to the network. This network how much it draws. This load is drawing. See the arrow itself, it's showing the direction of power flow. So it's going this like this direction, and also this is going for this direction. We are using a transformer to step down, and we are using like that. So this is very simple things, and we should be clear on this SLD because in further days we have to talk more about these drawings. We should be clear about this SLD, and next we are going to see about this the same SLD preparation. We are going to talk about the symbols. What are the symbols involved in the SLDs? So before that, I have to talk about the bus bar arrangements. Here, if you see, this is a single bus. For just consider this is a bus bar. It's a single bus arrangements with one load. 3 loads. So this is simple construction. So likewise, what are the types of bus bar arrangements available in the power system? The major constructions. I'm going to show you here. So this is the single bus. Single bus means only one bus with some other feeders. Only one bus is connected and some other feeders are connected to the single bus. Then next level is double bus. Double bus is nothing but we have to place one parallel bus with the single bus with one more parallel main bus. Next is main bus and transfer bus. This is same like a double bus, but we call it as one is a transfer bus. And ring main connection. I think ring main connection, all of them know about this. There is a ring type of bus bar arrangements used to do. And the major construction is one and a half scheme. We call it as one and a half bus bar. That means 1 by 2. Two bus bar share with 3 breakers. So we call it as 1 by 2 bus, because one bus is sharing 1 by 2 of the breakers. Then double bus with the transfer bus. So these are the evaluation we are using in the power system. So these are the types of bus bar connections. The next we are going to talk clearly about, that means elaborate about these bus bar arrangements. So this picture is showing the single bus with the source and loads. So this is the source. It's connected to the single bus bar and it's evacuated to the loads. These are the outgoing feeders. This is a source, single bus and the loads. So here we are using isolators, breakers, circuit breakers and everything. So in detail, this is the overview of a single bus. In detail, I am going to explain about the equipment. That means what are the equipments with the symbols. So the single bus is low cost and simple to operate, but disadvantage means it's required more time to make a maintenance. If there is a shutdown, everything will be shut down. If a simple shutdown came, means it will shut down a whole substation. So that is the difficult and disadvantage in the single bus. Next we go for the double bus. Okay, this is main bus with transfer bus. That means one single bus and with the transfer bus. We call it as main bus with the transfer bus, which means we are using one as a main bus bar and one is a transfer bus. The transfer bus is nothing but a same type of main bus bar, but we use this bus bar only during the maintenance period. Without shutdown the substation or any other equipments, we can transfer the load from our main bus to the transfer bus. Then we can make a maintenance operation. Then we can turn both the power flow. But advantage is simple, same the maintenance time. During the maintenance time there is no interruption of power. But disadvantage, during the fault clearance there is a problem in the transfer bus. Fault will not be clear automatically. That means fault clearance is not possible, because here the transfer bus there is no breaker. It's a isolators. All the transfer bus is connected with the isolators. If there is any fault occurs, there is no breaker to interrupt the or isolate the power. This is the main disadvantage in the transfer bus scheme. So next is ring main. A ring main is already know, I think all of them know, it's a ring type of arrangements. You can get the power from any directions. Even if you want to make a maintenance of this portion, I can shut down this without interruption of any other feeders. I can make a maintenance here. Advantage is flexible for operation and easy for maintenance, but disadvantage is high cost. Because of these arrangements, we have to invest more. We have to construct the ring type. The next one is 1.5 scheme. I already told you the 1.5 means 2 bus bar with 3 breakers. Here 1, 2 and 3 breakers. So these 2 bus bar is sharing the 1.5 breaker. So this is what this is called as 1.5 bus. Here also we can use the maintenance, and also without any interruption we can evacuate the power. So here it's showing the three breakers. So whenever the fault, this is a line or any load, you can call it as a load or source. This is connected to this bus through like this, this is connected, and also we can connect to the second bus. One line or one source is connected to the bus 1 and also bus 2. So this is what we are using, this type of arrangements. If I want to make a shutdown or make a maintenance of this line or this portion of the bus bar, I can do the maintenance with this breaker. I connect the source to the bus 1, also to the load. So without this bus bar, I can give the source and also the load. This is what the one-off scheme is using. Now in our TNEB we are using 400 kV and above, we are using this one-off scheme only. So disadvantage means is investment and also the space requirement is more. That is the only disadvantage. And also advantages means it's easy for operation, maintenance and everything. And this is a double bus with the transfer bus. So before we saw one bus with the transfer bus. Here we are using double bus with the transfer bus. We are using two main buses, and here there is a transfer bus. This two main bus means this is a two main buses using here. That means we are getting the power or evacuate the power from bus 1 or bus 2. So there is only one common breaker here. This is connected to the bus bar. There is a isolators. If I want to transfer power from bus 1 to bus 2, I can close this isolator, then it will transfer to the bus 2. During the maintenance, I want to maintain the substation without shutdowning anything, means I can just remove these two buses. That means the power is coming here, I open this isolator, the same time I close this one. So the power is directly flowing to the transfer bus. So this transfer bus is now energized. Now I can getting or giving the sources from this bus bar. That means I can get the source to the transfer bus, and also the same time I can evacuate. That means output feeder also connected to the transfer bus through this isolator. Here also the advantage and disadvantage is it's required more space and also the more investments. That is the main disadvantage here, but advantage is more. We can use the operation wise, and usage is very simple. Now we go for the ANSI codes. Here I mentioned only a few ANSI codes which are using frequently in the protection switchgear. So ANSI codes is available in the internet. You can download and also go through the ANSI codes. In future days we have to talk some most of the things in the ANSI codes. So ANSI code is nothing but a simple code which is understood by everyone all over the world. That's why the ANSI codes are using. So here I mentioned some ANSI codes. So just go through this one. So these are the few ANSI codes we are using in the protection side, also in the construction of SLD or any other things. Equipments also named with these ANSI codes only. In future, all the equipments, that means in upcoming 2 days we are going to talk about these ANSI codes only. In the name of protection we are using this one. So here it's mentioned this is a line switch. Line switch means isolator, and the same time, see, this is a lockout, master trip, relay, like that. So here just go through these ANSI codes. We talk clearly about these ANSI codes in further slides. Next we go for the symbols. See, majorly we are using the symbols in the construction of SLD. SLD, I think you all know, SLD is simple. It should be simple and it should be understandable by everyone. So the symbols are very much used in the SLD to understand better. So these are the some. Here I mentioned some symbols. So this is the motorized operator, the motorized operation of circuit breaker. The circuit breaker is operated by motor, and this is motor operated disconnectors. So we can call it as disconnector or isolators. But here this is a hand operated. So the symbol you should be clear. In further days we are going to talk about the SLD or any drawing with these symbols only. We are going to read the scheme with these symbols only. So just go through this one. This is the earthing switch, current transformer. Current transformer is just a line with a ring. This is the voltage transformer, surge arresters, wave trap, and power transformer. And these are the equipments we are using in the switchyard or switchgear. This is a heavy MV or LV equipments. So this is the contactors. Most of the time these type of equipments are used in the secondary wirings, secondary side. This is the NO contact, NC contact. It's a changeover contact, and here the same test switch. And this is also the same type of contact but with a double layer. So connections, if you make this type of connection, means it's a terminals. It's a terminal. It's generally we can make it as a connection by like this, and this is the connection with the disconnection type. This is a disconnection type, and this is a link. Terminal links, we call it as terminal links, and this also same type of simple connection, also disconnection type. And next one is earth and earthing contact, and this is a displex. And here it's mentioned a circuit breaker, but this is a mini circuit breaker. We call it as MCB. MCB, and this is a symbol for push button, and this is the switch position. See, please clear on this one. This is switch positions. There is only two switch here, only two positions, 0 and 1. That means on or off. This is on, off, and next one is switch with the three positions. That means we can make it as a local, remote, or SCADA like that. Otherwise we can make it as a neutral, trip, close. We can make like this. Next one is relay. Relay means it's a simple coil type. We can mostly we are using this symbol for relay, and here this is a bistable relay. That means set and reset. We can make a set, also reset. So these are the internal drawings for the, that means internal symbols we are using in the protection scheme. So this is the symbol for power supply of the any other electronic devices power supply. This is the binary input. Binary input means you know, I think 0 and 1. This is the output. We can get output from the protection relays. These are the symbols for relays with the input and output. This is the analog input. This is analog output. Analog input means it's a current or voltage or any other things. Analog output means it's a, we can generate some output from the relay. That means 4 to 20 milliamperes we can generate. It's like a transducer. And this is the optical interface. We can connect a protection relay from remote also. We can monitor the relay from the remote using this optical fiber. And this is the symbol for lamp and resistance, diode, I think LED diode like that. So next, this is a, just careful about this one. This is a very important things we have to show you. How you have to identify the elements in the drawings. How you have to identify the elements in the drawings, I will show you. Here, this is the actuator. That means it's a simple electromechanical relay or like that, any other things. If this is what the relay or any other symbol is mentioned in the drawing. Likewise, they will mention, means you have to know what is this component, why it's placed, where it's placed, what are the purpose. So here it's placed here, the name is K2. This is the name of the component. Here it's mentioned the name of a component. So this is the main coil. That means main coil, we will give the positive and negative, then it will operate. So based on this operation, these are the associated contacts. From this coil, it will change the positions from NO to NC or NC to NO. Whenever this actuator is activated, these contacts are changing their positions. So this is what they will mention here. In the drawing itself, they will mention like this. Below this K2, they will mention like this. Otherwise, they will use this contact in some other pages or somewhere in the drawing. So how we have to identify from where this actuator is coming? So you have to read the name. Name is K2. If you are going to read this K2 anywhere in the drawing, you should remember this K2 is from the DC distribution. This the name of the function. This is the function name, and the name of the relay or actuator. This is function of the actuator, and this is the page number. Here it's mentioned page number of the actuator. This page number is mentioned in the drawing. You can go to this page number. For what purpose this actuator is used, you can find. So here, whenever the actuator is activated, it's changing the contact from NO to NC. Here it's shown, this contact is elaborated here. Just consider this one. So the terminal numbers 11 and 14, it's a NO contact. 11 and 12 is a NC contact. So here it's mentioned that this is the terminal numbers, and this is the function. This is the name of the actuator, and here it's mentioned the link. Link reference to a symbol means this page number. This is the page number. This page number, if you go to this page, this will give the detail about this relay. If you are going to read the drawing if you find this contact somewhere, it's mentioned the origin here. So here, if you go to this page number, you can find this actuator for what, how it's operating, and this is the contact details. Here I will mention the contacts, where the contacts are used, from where to where the contacts used, what are the purpose they are using this contact. So this is the simple identification, how to identify, how to read the scheme. And before that, you should aware about the actuators, relays and everything. This is the basic thing. We have to read the name, function, terminal numbers and the page numbers. Then we go for the protection relay. For protection relay, we make a name like this. It's a simple name. The name is depends upon the designer. The name is depends upon the designer. Then they will make a function, protection generator A. That means it's a function of the relay. Type is, this is a model number, model type, and operating voltage. Here it's mentioned the operating voltage, and here the manufacturing reference. So here it's mentioned, this is a terminal details, terminal or cord detail. So this is the terminal numbers. Here it's mentioned the terminal numbers, and before in the last slide we saw this is the symbol for binary input. So the binary input means it's collect the input from the field in the form of DC. Whenever you are giving a positive and negative, it will give the result of 1. So that DC is carrying the information. That means DC voltage is carrying information from the field. So here we can name the binary input. What are the information? What is the information carried from the field? For what purpose we are using this input, and what is the voltage level, and which page they are using here, which page they are using the input. So this is the polar angle. It's a name. It's used for the loss of synchronization. So generator means we are using the synchronization function. When it is lost the synchronization, the input is given from the field to the relay in the form of DC. Whenever you are getting the DC voltage, it's become 1. It shows the polar angle. That means the loss of synchronization is happened. So we have to shut down the generator. It will understand like that. We have to make a program to shut down the generator. So once I receive this input, I will make a program to the relay. I will make a program in the relay to give a command to shut down the generator. Likewise, we can use different type of inputs to the relays. So next, this is also same relay. Here mentioned the page number of the relay, but in the previous page is not mentioned the page number of the page number, from which page they are using this relays. That means the scheme drawing is nothing but a simple blueprint how the manufacturing done, but the blueprint is it's not simple drawing, it's a very big drawing. It's going like nerve system. So we have to make everything in the simple readable format. So that's why we have created this drawing in the multiple pages with the internal connectivities. So this is a simple SLD. Here I am showing a simple SLD with the 2 busbar, 2 isolators, 1 breaker, CT, and again one more isolator, then it's going out. So this is a simple SLD in the drawing. This drawing I will share you in the last of the session for the homework. You can read this drawing in your home. So here this is the bus bar. See the transmission line. This is a 230 kV transmission line. First we have to read the drawing in detail. First, what is this drawing? Which drawing is we are reading? What are the equipments placed in the field? This is a simple representation of field. So in field we can find 2 bus bar. This is 230 kV system. It's mentioned clearly here. 230 kV OHL metal line. That means the name of the line and the kV level. It's mentioned. So in the construction of SLD, we already saw the system voltage. First we have to mention find the system voltage. So here it's a system voltage is mentioned clearly, and the type of arrangement is double bus. This is the double bus, bus A and bus B. We have 2 disconnectors, 1 breaker. This is the symbol for CT. Here I'm going to show you. This is a symbol for motorized operation circuit breaker. Here motorized operation disconnectors. This is the symbol for CT. Again we are going for the motorized operation disconnector, and this is the hand operated earthing switch. So here they mentioned hand operated earthing switch, but it's make one interconnection. See, there is a line with one triangle. There is a connection between this earth switch and the isolator, which means this is the symbol for interlock. Interlock means there is a lock between operations. So next is going to the connected. This line is connected to the potential transformer. This is CVT. We call it as capacitive voltage transformer. This is CVT. Then this is a surge arrestor. Then it's going for the line. So this is a simple construction made in the field. Here it's clear about the field equipments. These are the HV equipments. So here we can find the HV equipments. Now we are going to talk about the secondary things. These are the primary. Now we are going to talk about the primary things. So primary is here. So the primary is giving the secondary information. So CT is connected to the protection relays. DT also connected to the protection relays, and the breakers, disconnectors, everything is connected to the monitoring and the control devices. So here it's a simple constructions mention the what are the analog inputs given to the relays, what are the protection relays available in the system. For this is called as a one bay. Bay means it's a space specially given for this particular line. Bay means a space, a defined space for this line. So here we can find CT 1, 2, 3, 4. That means 4 cores. This is called core. We saw that double winding. In example, we saw double winding, but this is 4 winding CT. The ratio is mentioned here 400, 800, and 1 by 1. That means this CT having a tappings of the maximum tap is 800, the minimum is maybe a 400 or 200. So this CT is connected to the secondary port. Here it's mentioned the panel. Here everything is mentioned with the panel numbers, panel name. Panel means is nothing but the panel which is having a protection relays, switches and everything. These are the control and protection compartment. The same control and protection compartment. This is the control and protection compartment. So here they mentioned as a control panel and a protection panel. So the CT is going to the protection panel, also to the control panel. So here we can say the core 1. We trace the core 1 is going to connect in the protection panel. It's connected with one relay. One relay means the relay having a name of F21. We saw the 21 means a distance protection relay, the ANSI codes. So that's why I saying ANSI code is very important. So just go through the ANSI codes. What are the ANSI codes we are using in the power systems? I mentioned in the slides. And next one is the different CT is going to the different protection and also the meterings. So this is the one panel, this is one panel, this is one panel. This is placed in this dotted line. So this dotted line means this is one location. So this is one location, and this is one location, and this is the different locations. So whenever the line is crossing from one location to another location, we have to be clear on that. So I will give the schematic drawing to you, how to read the schematic drawing and everything. So next I will go for the safety. Safety means we have to follow some safety rules on the field during the working or any visiting time. So I will give some basic tips in the safety. So before you are going to start the work, you should be a permission. That means you need a permit to work in the particular place. You should get permit from the authorized person, and you should inform the permission about to the workers or peoples nearby you. So this is work instruction. Work instruction is nothing but there is a defined instruction to you. You are the professional engineer or any professional engineer. You know the working, but the place where you have to work and what are the types of work you have to do in that time of allocation. And this is a lockout. Lockout is nothing but you have to make yourself safety. Your safety before this lockout is nothing. You lock the place for your safety. It will avoid the unauthorized operation or unauthorized entries, and you should not allow any unauthorized person on your place. Whenever you are working in the height, you should wear the proper PPE, the personal protective equipment. PPE should be always used during the work. Confined space means if you are going to work in the confined space, you should be with one assistant or any other helper with you to assist always. You should wear the seat belt and follow the speed limit inside the working place, and you should not go anywhere in the suspension load. You should not allow to work or stand in the suspension load place. Don't use the mobile phones while driving, and during the work you should not allow to consume any alcohols or drugs. Smoking also prohibited inside the working places. And this is a fine basic electrical safety. You are going to work with electrical, you should cut off the source. Next, you should lock the place, so it will avoid to turn on by any unauthorized person, and you should verify the absence of power. Next, ground the system. Next, you can make a signage working is going on like that. So we have some different sign categories. This is prohibition, this is mandatory, warning sign, safe sign, and fire safety. So here the signage is showing the prohibition, not allowed firing, not smoking. Mandatory means you should wear the mandatory PPEs and everything. Warning is nothing. It's a warning for everyone. So these are the basic PPE you should use in the site during the work. Minimum PPE you should use in the work site. So accident, incident, near miss, you should inform about the accidents or incidents or near miss. Near miss is nothing but you are going to meet any accident but you are missed by your luck. You should inform about this to your supervisor or your safety manager. This is the recording is a reporting, and recording is very important in the safety procedure. Whenever you are facing any incidents or accidents in your work site, you should report immediately to your manager or safety supervisor. This will help you to the help others to avoid this type of accidents. So this is simple things you should follow during the emergency time, fire and medical emergency time. These are some things common to everyone. So just click the I paste the drawing here. Just download the drawing and go through the drawing how to read, and you just read by yourself. If you have any clarifications, we will do it tomorrow. And here I mentioned the link for the drawing. Thanks everything. Here this is a feedback form. You should fill your feedback. It's helpful for us to improve ourselves. And thank you. See you tomorrow. So I will paste the link in our live chat. Just go through the link and download your feedback. So for drawing the SLD, we can use any CAD, AutoCAD or ETAP. For analysis, we are using ETAP software for fault calculation and everything. And also, we can go for the most of the people they are using ETAP for SLD construction and AutoCAD. The interlock, I think someone has a question is interlock. Interlock is nothing. We can talk clearly about this interlock by tomorrow. Interlock is nothing but a lock between the operations. So one operation has to complete for the next operation. That operation is called as interlock, which is used to control the operation and also for better operation. Without any fail, you can operate or you can avoid the mishandling of equipments. Thank you. Thank you everyone. See you tomorrow with interlocks and everything.